Hi, everybody. We're here talking about 10.2 notes, angles, and arcs. I want to talk about a little bit of vocabulary first. The central angle is the first vocabulary term we're going to learn today. A central angle is an angle whose vertex is on the center of a circle. So this angle right here, angle AOC, the center of the circle is O, and so this is a central angle. An arc is just a part of a circle. So if you look at this whole picture right here, the red part is the arc that they're talking about. There's another arc that's the part that's not the red part, but for our purposes here, that arc is just a part of the circle. There are three different kinds of arcs. The first one is a minor arc. A minor arc is above a central angle, and that angle has to be less than 180 degrees. So if you look at our picture here, this red section of the circle is our minor arc, and it's connected to that central angle. It's less than 180 degrees, and so we can use two endpoints to name it. So this is minor arc AB. A major arc is an arc that is above a central angle, so this is also a central angle over here on the other side of C. And it has to be greater than 180 degrees. We have to use three endpoints to name it because our default is to go the shortest distance. But if we want to make sure that you understand that this is the major arc, which is the blue part of this circle, we need to have 3 points so that you know to start at A and go around the circle to D and then finish at B, and that's the length of that whole arc. A semicircle is another type of arc, and I like to think of it as the Pokeball of, how it's just divided into two colors. If the central angle equals 180 degrees, then the arc is a semicircle. So basically, if this line here, AB, is the diameter of the circle, then you create two semicircles, one on top and one on the bottom. The measure of an arc. The measure of an arc is the same as the central angle. So here, angle ABC is 30 degrees, and so arc AC is also 30 degrees. The measure of an arc is the same as the central angle. So here, arc AB is 120 degrees because that's what they tell us the central angle is. To figure out what the other arc is, what major arc ADB is, we would take the total of the degrees in a circle, 360, and subtract what we know, 120, and that other arc is going to be 240 degrees. The last thing I want you to know about is that arcs can be added together. So if we know that arc QP is 83 degrees and arc RP is 27 degrees, we can add them together to figure out that arc QR is 110 degrees. All right, now that we've studied the vocabulary, let's go ahead and take a look at a couple of examples. This right here is circle O, and I know that because it's got an O right here next to the point that's in the center of the circle. And they've given us some information. So segment BT is a diameter of circle O. Now what that means is that if it's a diameter, that you create a semicircle and that these two arcs together add to 180 degrees. And since the central angles are the same as the arcs, these two angles add to 180 degrees. So 180 minus the 48 tells you that this angle is 132 degrees, and therefore this arc is also 132 degrees. The other piece of information that they gave us is that the measure of arc KT is 105 degrees. So since this arc is 105 degrees, the central angle that goes with it is 105 degrees. Now it's on the other side of this diameter, so these two angles add together to make 180. Therefore, this one has to be 75 degrees, and this arc is 75 degrees. Let's fill in a little bit of what we know. So our angle KOT is just the same as arc KT. This is 105 degrees. Angle BOH is 132 degrees. Arc BK from here to here has got to be 75 degrees. And the measure of major arc BKT. BKT. Oh, you know what? BKT is actually a semicircle. That's 180 degrees. You would add the 75 plus the 105 to find that. This is another major arc, and I know because it's got 3 letters in the name. H, T, all the way over to B. So I'd add 75 plus 105 plus 48, and I get 228 degrees. And then another major arc, BHK, is basically everything on here except for the 75. So this is 285 degrees. All right, so the next thing that we're going to learn about is something called arc length. And arc length is the distance between the endpoints along the arc of a circle. So since the arc is a part of the circle or a portion of the circle, its length is a fraction of the circumference. So this is our formula in this box for arc length. You're going to take the measurement of that arc divided by 360, and then you're going to multiply it times the circumference, or 2 pi r. All right, so if the radius is 8 inches, find the following arc lengths. So first of all, I want to start out with finding the circumference. Circumference is 2 pi r, and if our radius is 8, it's 2 pi 8. And then if you want to simplify that further, it's 16 pi. Okay, now for finding an arc like BK in our picture was 75 degrees. So 75 divided by 360 times 16 pi is what we're looking for here. Now there's 2 ways that you can leave your answer. You can leave your answer in terms of pi, and for that we're going to want to put it in a calculator. So I've got Desmos pulled up over here, and it'll give you an answer in a decimal or a fraction. I like it in a fraction better. So this could be 10/3 pi is one way you could answer it. Or you could go ahead and add that fraction in there, 10/3 times, and you should have a pi button on your calculator, pi, and you get 10.47 inches. Okay, so now let's look at BKT. BKT from up here was 180 degrees, so we're going to do 180 over 360 times 16 pi. All right, so when you do this, this basically is half, right? So 180 divided by 360 is 1/2 times 16 pi. So you end up with 8 pi as your exact answer. But if we wanted to put it in the calculator, we would say 8 pi, and it would give us a decimal of 25.13 inches. Okay, and next for HTB, same deal. You find the angle measure, 228 degrees divided by 360 times 16 pi. And of course, you can put that in your calculator. It does come out to if you put it in without pi, you get the fraction. So 228 divided by 360, and then arrow over and multiply times 16. Now it wants to give you a decimal, but if you push this button over here, it'll give you the fraction. So I can say that this is 152 over 15 pi, or I can take that number, 152 divided by 15, and multiply it times pi and get an actual decimal. So 31.83 inches. All right, last one, BHK, we said it was 285 degrees. So 285 divided by 360 times 16 pi. All right, let's go ahead and put that in the calculator. Times 16, and as a fraction, we get 38 over 3 pi. That's our exact answer. Remember with pi, because it's such a big decimal, you don't ever really get an exact answer because you have to round it. So 38 divided by 3, and then times pi. You've got a pi button on your phone and on this Desmos calculator. So 39.79 inches. Okay, that's the end of our notes. Go practice on those practice problems for today. Have a good one.